Hello everybody, so we're going to have a look at how we can find the uncertainty from multiple trials. Now your video might have the multiple trials on one video, or you might have separate videos. Either way, you can import all three videos to work out the separate trials, or have three separate capstone files and then work out the gradient and therefore G from that, and therefore work out the uncertainty in G. So I'm going to start video analysis mode now by making sure that that is selected here at the top, and then click on my loop and then start to plot some data. I'm going to do it real quick because I'm aware that you guys have got zero time to look at the data, or at least the video that I am doing. And I'm going to do this 3 times to simulate 3 different trials. So we're just going through, and this is object 1, and then I'll create object 2 and object 3. And that'll simulate my 3 separate trials, and I'll show you how to get that data from there. I'm just going to keep going until we get all the way down to about there will do. So I've got my first object there. Actually, what I need to do as well is just check the calibration tool by making sure that that is at a meter. So that one there and that one there. I'm doing it rough. You can spend a lot more time on it than I can. And then we're going to create a tracked object. So this will create the second trial basically. So when you've done your first trial, scrub to the part of the video where you got your second trial and then click on create tracked object. And you see here now it says object 2. So I'm going to go back into here and I'm going to scrub the movie all the way back to when I did it the first time. About there. Let's go back a few. About there, and I'm going to start creating more trials. Let's do it a 3rd time. In fact, to save time, let me just do it 2 times. You're obviously going to have multiple trials or more trials than 2, but for the sake of expediency, I'm just going to do it 2 times so that you guys can see what is required of you. I'm just going to go through and make sure that, and you're going to make sure that you do it in the center of the object. But again, you know, it really is important that you guys be as accurate as you possibly can within reason. Last one, there. Okay, so I've got now 2 trials effectively, and I've set my calibration for my tool. If you don't do this, by the way, your value for G is going to come out wrong because these lengths will all be wrong. So now I've got that, I'm going to stick in a graph. So I'm going to pull a graph into that space there. And I want 2 graphs on the same axes here. So we're going to click on this, add new plot area to the graph display. So I've got 2. And I want to choose object 1 and the velocity, and object 2 and choose the velocity. So that's that one there, Vy. Make sure it's in the Y direction. Let's press this button to make sure everything appears on the screen, and let's smooth that data out again like we did last time. So click on this button and just smooth it out so it kind of looks like a straight line. Same with this one, smooth it out so that it kind of becomes a straight line. And what we need to do now is to make sure that we're not counting this part, and this is basically where it's hit the floor at this point. So I'm looking to see around about here that it hasn't included those points. So the way to do that is to create a highlight box, okay, and you drag it over till you highlight the ones that you don't want anymore. So when it starts turning up, I'm going to include that one there. And then if you right click on that box and go to exclusions, you can exclude that highlighted data, and you notice there that it basically doesn't include that one. Let's do the same for the other graph. There, move it over, move the box so it encompasses everything that you don't want anymore, like that. Right click, exclusions, highlight excluded data. So it's only going to count this part, which is like my my straight line, although it's not very straight. Make sure you're in the graph that you want to put the equation on, and then we're going to pop up to this one here and put a linear trend line on there, like that, and then move that over. You'll notice minus 10.5 is pretty close to minus 9.8. Go to the next one and do the same with that one. Linear, like that. Okay, 10.6. So now you've got two values of g, because remember this is a VT graph and the acceleration is shown by the gradient of the graph. Then you've got minus 10.5 here and minus 10.6 here. So those are your gradients, which is also the value for g. And so you can find out the average from those two, and you can also find out the difference and therefore the range and therefore the uncertainty in your value for g. Now, one more thing that you might need is the intercept. And this value here, if you're trying to find out, any of you, how to find out the launch velocity is obviously when it's 0, right? That c value is 0 or crosses the x equals 0 axis. But this isn't right at the moment. That value for b, which is the intercept, 69, you didn't launch it at 69. You launched it way, way slower than that. So I'm just going to grab hold. I've left clicked on there and I'm moving over, and I want to grab hold of the coordinates tool, which is, I believe it's that one there. Okay, add coordinates delta tool, and it'll pop up in the graph that you have chosen, and then you can move this around. You'll notice it moves it around so that it highlights each one of those points. So I'm going to highlight that one there, like that, and that'll stay on the graph then. So if I move that around, you'll see just about there that it's showing what the coordinates are for that particular part. So on the x-axis, it's 6.052 seconds, and on the y-axis, it's 6.35 seconds. So at that time, when it left my hand, the y-coordinate was 6.35. That's basically your launch velocity. But we can do the same to this one as well. Click on that, go to the coordinates tool, add coordinate, and that's gone right in the middle, so I'll just undo that for a second there, move it till I've got a bit of space, and then try it again. Add coordinates tool, there, that's better, I can move it now, there. Okay, so that launch velocity was 4.64, and then again you can get an average of those two when you go into there. So nice and easy to be able to work out your mean values, to be able to work out your uncertainties and your gradient, and therefore g, and to be able to work out what the launch velocity is. And again, average launch velocity is going to be the average of these two, 6.35 and 4.64, and then you can work out the uncertainties in that. To work out the uncertainties in the time, all you need to do is estimate what your errors in the time would be, and you just put it on the x-axis. There's no need to put error bars on each one of these, and I'll do a separate video for the error bars a little bit later. I hope you thought that was helpful.